Hello, class. I am from Guangxi Financial Vocational College. Teacher Yi Ziwan. Welcome to the statistics class. Let's take a look at the year 2024. News released by the State Administration for Market Regulation. A certain batch of pure milk from a dairy industry was reported by consumers for the issue of weight not meeting the standard. Regulators did not check each of the 100,000 cases of milk in the warehouse one by one. Instead, 200 boxes were randomly selected for testing. Based on the sample data, it was ultimately determined that the products in this batch from the enterprise were short on weight, and penalties were imposed in accordance with the law. Think about it. Why can regulatory authorities draw conclusions without inspecting all products? This method is the sampling survey that we will learn today. To see how to use small data solving big problems. The core of the sample survey is to select sample of the population randomly by studying the characteristics of the sample to investigate the quantitative regularity of the population. Just like the milk case of a dairy industry just now, 100,000 cartons of milk were the totality of the study. The 200 boxes taken are the samples. We also need to pay attention. Overall is the only certainty, but samples can come in many varieties. For example, selecting 50 people from 1,000 students. There can be tens of thousands of different extraction combinations. But no matter what combination, must follow the principle of randomness to represent the whole. After understanding the basic concepts, we can enter the sampling process. There are 4 core approaches, which can help you to solve practical problems. Method 1. Simple random sampling. This is the most basic method. It's like numbering a carton of milk. Then use the random number table or select samples by drawing lots. So here's another example. Draw 10 students in a class. To investigate the complexion of assignments, write the student number on the note, disrupt it and draw it. That is the simple random sampling. But it has a limitation. If the overall scale is large, for example, if we want to investigate the tax payment status of 10 million small and medium-sized enterprises nationwide, it will be difficult to operate the numbering and lottery methods. The second method is classified sampling. This approach is smarter. First divide the population into several categories by characteristics, and then draw samples from each category. For example, investigate the sales of a certain mall. You can press the floor first, food on the first floor, and clothing on the second floor for layering. Then randomly select 10 stores on each floor. The key to layering is small differences within layers, large differences between layers. Just like the difference in sales between clothing stores on the second floor is small. However, food and clothing vary by category, so there is a big difference in sale. It should be compared separately and sampled separately. The samples drawn this way will be more accurate compared to simple random sampling. Stratified sampling can reduce errors, especially suitable for obvious differences on the overall interior. The third method is isometric sampling. Determining a sampling interval at first, and then we take samples from the population at these intervals. This method is easy to operate, suitable for cases where the overall distribution is uniform. For example, the school library has 5,000 highly borrowed books. The administrator wants to know the average borrowing duration of these books. A copy of Chatu is time-consuming. This is where isometric sampling comes in handy. The first step in isometric sampling is to rank the population unit. Library books have unique collection numbers, from 1 to 5,000. It is very convenient to order the number directly without extra organizing. Then calculate the sampling interval. Suppose you draw 500 copies as a sample. The sampling interval is equal to the population divided by the sample size. So 5,000 divided by 500 is 10. That means 1 every 10. Then determine the starting point, using a random number generator, to choose a number from 1 to 10. If you draw 7, the draw number is 7. Books from 1727 up to 4,997. 500 copies in total. The advantages of this kind of sampling are obvious. One is simple operation. Unlike simple random sampling, you have to look everywhere for books with different numbers. Second, the sample is evenly distributed, from 1 to 5,000. Evenly distributed good representation. But be careful, it's easy to make problems if the book numbers are regular. For example, according to every 10 books as a set, textbook number interval 10 sampling may draw the same kind of book. It might make the results inaccurate, but library numbers are generally in the order of purchase, so this situation is rare. It's easy to be seen that the isometric sampling is suitable here. Method 4 or cluster sampling. It will be divided into several groups as a whole. We're taking random samples of the population composition. Conduct a survey of all units of the selected group. For example, everyone loves online shopping these days. An e-commerce platform wants to know the satisfaction of our school's 1,000 frequent shoppers. These are 1,000 students are divided into 10 groups according to dormitory buildings. With 100 people per buildings, the cluster sampling procedure is as follows. First, divide into group based on the 1 to 10 dormitory buildings. Each building with 100 students will form a group. No additional grouping required. Then randomly draw the group. Randomly select 2 buildings from 10 buildings, such as Building 3 and Building 7. Finally, investigate and draw all the units in the group. The survey included 200 students in Buildings 3 and 7. Ask them about their online shopping satisfaction. This approach has obvious advantages. Easy to organize. Instead of looking for 1,000 student contacts one by one, directly contact the building chiefs of the 2 buildings to help organize, which is save time and effort. However, the shortcomings also need to be noted. If there are large differences between groups, the results are also biased. For example, Building 3 is mostly for freshmen with less online shopping experience. Building 7 is for seniors who often shop online. The results of the 2 buildings may not be representative. Overall situation of 1,000 students in the school, so cluster sampling is suitable for large intra-group differences and small differences between groups. It's applicable for the students in each dormitory buildings who has similar online shopping habits. So here's the negative example. In 2023, a listed company was audited in its annual report. To save costs, the accounting firm deliberately selected several subsidiaries with good performance as samples, instead of adopting random sampling, ultimately concealing the fact of overall losses. Punished by the China Securities Regulatory Commission. This case shows us that, as a future financial practitioner, sampling survey is not only a technique, but also a responsibility. Behind the principle of randomness is objective and fair professional ethics. Error control embodies a professional attitude of striving for excellence. Finally, let's summarize. Today we learn the basic concepts of sampling surveys, for sampling methods and application scenarios. I hope that in your future studies, you can not only master the technical methods of sampling, but also adhere to the integrity principles behind data. Please think after class. If you want to survey the satisfaction of school cafeterians, how to choose a sampling method. In the next lesson, we will share the answer.